Alright guys, in the last video I want to look at a quadratic that's in standard or general form. Now standard or general form looks just like the one which I've written here, which is y equals ax squared plus bx plus c. We're going to do the same thing with this as we did with the others. It's important that we get those good points, the intercepts, the vertex, reflections, those types of things. So let's go ahead and go right into it, and then we'll talk about some of the shortcuts and other things that might be helpful. Now, in most cases, we could actually look at this and we could factor it. This case won't actually factor, so we're not going to factor this one. What we are going to do is we're going to use the quadratic formula. And so we would go x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we can go ahead and do that, and we will find the x-intercepts. So that would be negative 6 plus or minus the square root of 6 squared minus 4 times 2 times negative 3 all over 2 times 2. All right, now let's go ahead and do that real quick. All right, very nice. So we got x equals negative 1.718 and 0.218. So if I go ahead and I put those intercepts on my graph, there is the 0.218 and negative 1.7, so right there. So we've got our graph ready. So now those are the x-intercepts. We do want to find the y-intercept. The y-intercept we can get by, of course, plugging 0 in for x. So if we put 0 in for x, this becomes 0, this becomes 0, and so we've got y equals negative 3. So y equals negative 3 is my y-intercept. Okay, now we know that the axis of symmetry is right in between these two. And so we can take that 0.218 and the negative 1.718 and find out what's right in the middle. So let's do that. We'll take 0.218 plus negative 1.718, and then we'll divide that by 2, and we get negative 0.75. So at x equals negative 0.75 is the x value of the vertex, which is also the place of our axis of symmetry. So that would be right here, right? There we go. Now that does a couple of things. One, it allows us to take our y-intercept here and reflect it on the other side. And then secondly, it will allow us to find the vertex itself. So we'll go ahead and plug negative 0.75 into our equation. So y equals 2 times negative 0.75 squared plus 6 times negative 0.75 and then minus 3. And we get negative 6.375. And so we can put our vertex at x equals negative 0.75 and the y value of negative 6.375, which will be somewhere down here, right there. And so now we can draw our graph, which should look something like this. Oh, that guy's skinny. He is so skinny. There we go. All right, so then we have our quadratic formula. Now, a couple of things I wanted to mention. The first thing is, obviously, for any standard equation, you can always get the x-intercepts by using the quadratic formula. Even if it's factorable, you could use that. And so I just wanted to show you this. X equals negative b plus, and I'm going to put the discriminant, and for the discriminant I'm going to put the symbol, which is just a big triangle like that, over 2a. Or it could be x equals negative b minus the square root of the discriminant over 2a. Now go ahead and add those together, divide by 2, find out what you get if you get the middle. So you can see I took the two x-intercepts, added them together, divided by 2, and I found that the center point is negative b over 2a. That's why the x value of the vertex is this. Ta-da!